Welcome back to the Network Plus training series. Last lesson we did cables, the layer 1 problems you can usually see, touch, and replace. Now we go invisible, wireless. Where the cable is air, the signal is a radio wave you can't see. And every troubleshooting decision starts with, did anyone microwave a burrito recently? Objective 5.3, common wireless connectivity issues. Wi-Fi looks like magic until it stops working, and then it looks like the worst layer 1 problem you've ever debugged. Let's start with the villain that breaks more wireless networks than anything else: interference. The 2.4 GHz band is the public bus of radio frequencies, microwave ovens, Bluetooth, cordless phones, baby monitors, the neighbor's Wi-Fi. Everything radiates here. The 5 GHz and 6 GHz bands are quieter. More channels, fewer non-Wi-Fi devices, less competition. If you can move clients to 5 or 6 gigs, do it. Inside Wi-Fi itself, there are two flavors of self-inflicted interference. Co-channel interference, multiple access points on the same channel competing for airtime. Adjacent channel interference, access points on overlapping channels stepping on each other. In the 2.4 GHz band, only channels 1, 6, and 11 are truly non-overlapping. Pick anything else and you're paying a tax. Always plan with 1, 6, and 11. To fix interference, do a site survey, identify sources, plan channels with non-overlapping picks, move to 5 or 6 GHz where you can, and tune transmit power so APs don't shout over each other. Now coverage, slow speeds, drop connections. The user is in a dead zone, and they're right. Distance kills signal, so do walls. Drywall and wood, minimal attenuation. Glass and concrete, moderate. Metal, brick, and stone, significant. A metal filing cabinet between the AP and the user can block all of it. Building materials matter more than transmit power. To fix coverage, add APs in dead zones, reposition the existing ones. Check the antenna type. Omnidirectional radiates a donut shape and should be mounted vertically. Directional concentrates the beam and should be aimed at the area you're covering. And if coverage suddenly got worse, ask the obvious question. Did anyone build a wall, install metal shelving, or move the conference table? Authentication and association. The I can't connect problems. Wrong SSID. The laptop is trying to join the wrong network. Wrong security. WPA2. Client trying to join a WPA3 network or vice versa. Wrong password. The simple but stunningly common one. Radio server unreachable. Enterprise networks die when the radio server dies. MAC filtering. Somebody allow listed devices and forgot to add this one. Most of these show up as association succeeds, but authentication fails. When you see that pattern in the logs, walk through the list. SSID, security type, password, radius reachability, MAC filter, in that order. Roaming. The fun one. Sticky clients are devices that refuse to roam. They cling to a distant access point with bad signal instead of jumping to a closer one with good signal. They run slow. They drop. Their users complain. Fix it with minimum RSSI thresholds on the access point. Set a floor below which the AP will deauthenticate the client and force it to reassociate, which usually means picking a closer AP. Plan for 15 to 20% signal overlap between adjacent APs so there's always a stronger signal to hand off to. And use a wireless controller for centralized roaming decisions. The controller sees the whole network and makes better decisions than any one AP can. Channel utilization. Too many clients on one channel. Even with good signal, if a channel is full, everyone slows down. Fix it with band steering. Push dual band clients to 5 GHz so they stop crowding 2.4. Split clients across more APs. Reassign channels to reduce density per channel. Rogue access points. Unauthorized APs connected to your network. Could be malicious. Could be the marketing intern who plugged in their own router because the corporate Wi-Fi was slow. Either way, security risk and interference source. Use a wireless intrusion detection system, WIDS, to detect them. Run regular wireless surveys. When you find one, locate it physically and remove it. Antenna issues. Omnidirectional, where you want it directional. Directional, where you want it omnidirectional. Antenna polarization, mismatch between transmitter and receiver. Indoor antenna outside or outdoor antenna inside. Match the antenna to the use case, and remember, polarization needs to match on both ends. Captive portals. The hotel and coffee shop classic. The user joins the SSID, but the captive portal page never loads, so they can never click I agree. 3 things to check. DNS resolves correctly, so the portal hostname can be looked up. Browser security settings aren't blocking the redirect. The captive portal infrastructure is actually up. Most captive portal won't load tickets are one of those 3. Firmware and drivers. The least exciting cause and the most common. Outdated firmware on the access point. Known bugs, compatibility issues. Outdated drivers on the client. Connectivity weirdness that disappears the moment you update. Update both. Test in non-production first. The tools you'll reach for. Wireless site survey tools. Map coverage, identify interference, plan channels. Spectrum analyzers. See non-Wi-Fi interference that a regular site survey misses. Built-in wireless diagnostics on the client. Every operating system has them. The access point management interface or controller. See client statistics, signal strength, retrace. And Wireshark with a wireless capture when you need to see what's actually on the air. Quick recap. Interference, co-channel, adjacent channel, non-Wi-Fi sources. Coverage, distance, building materials, antennas. Authentication, SSID, security, password, radius, MAC filter. Roaming, sticky clients, RSSI thresholds, AP overlap. Channel utilization, band steer or split. Rogue APs, WIDS finds them. Captive portals, DNS, browser, server, firmware and drivers, keep them current. That is Objective 5.3. Next up, say Objective 5.4, Common Network Service Issues. The DHCP, DNS, and time problems that look like the network is broken when really it's one box doing the wrong thing. See you there.